Hello, and welcome to the ADVizE mini lecture on what are data. I'm Kristen Hunter Thompson, and let's jump in. So, before I jump in and talk about kind of what are data, I'd like you to pause the recording and think about these three prompts. List three words that quickly come to mind when you hear the word data. Write down two questions that quickly come to mind when you think about data, and then write one metaphor or simile for what data are. Okay. The point is that we're doing this quickly. It's just word association. What comes to mind when you think of data? So pause the recording, write your three words, two questions, and one metaphor or simile, and then come back and press play and keep going forward. Okay. So data are showing up in our news every day, all over the place, in all sorts of different ways. Sometimes even the visual of the story of the data visualization is what leads a lot more than all of the text. Because let's be honest, right? We only have so much time and we're scrolling. So the visuals are showing up in our news. Data shows up in our lives from, yes, this was my electricity bill back in May of 2019, and the electricity company had no problem charging me a lot more money for May 2019 than what they did in May 2018. And reading the graph, I was able to save some money. That's a side note, things like that. But they're showing up on our Fitbits, on our phones, all around us in our daily lives here in the 21st century. They show up strongly in our math class. You might remember the good old 4-quadrant graphs that we made in math class back in the day, where we're describing and comparing attributes, we're representing and interpreting data, we're converting measurements, we're using probability to evaluate outcomes and decisions, we're computing statistical analyses. So many different ways that data show up in our math classes, but also so many ways that data shows up in our science classes as well. We're using graphical displays, we're collecting data, we're thinking about relationships between data, analyzing and interpreting data, characterizing it, considering the limitations or the affordances, the precision, the accuracy of our data as we're going through and making claims and developing arguments from the information that we have in science. It also shows up in our social studies classrooms. Data are all around us. It shows up in our lesson plans where we're having our students work with data, real world data or data that they've collected to determine, to learn a specific concept that we are trying to get them to do. But here's the deal. For a lot of us, as we're in the classroom, as we're preparing for the classroom, realize our students are struggling with it. They're just not getting out of the data everything that we're hoping that they can get out from the data. So another way to kind of think about this is, rather than data being this separate thing, it is what we actually use. It is certainly what we use in the natural and social sciences to make sense of information. And so those of us that are going, like, thinking in the science space, we've got the three-dimensional nature of next generation science standards with the what students do, the what students know, and what students think. But data is what we use. And this is exactly the same for social studies. And it can be the same for our math classes, and data can show up in English language arts as well. So it is truly interdisciplinary. It can cut all ways. So then let's dig in a little bit more as to kind of what are data and how can we think about that? If that's it's all over the place, there are lots of visuals, there's lots of data, the word data showing up in our curriculum, and it can come up in all of our different subject areas. What is it? So let's take a step back for a moment. So how tall is this plant? If you have a way to measure the plant, you can figure this out. It is a number. This is a simple fact. You're going to measure the plant. Here I'm telling you it's 80 centimeters tall. That is the answer to this question. What is this plant? This is a number. How tall is this group of plants? Now we have data. because each plant has its own measurement that we can take. And in fact, we need to decide, we need to make some decisions as to what are we going to say is tall for the group. Are we going to use the maximum height of all the plants? Are we going to use the average height across all the plants? Are we going to use the range of the minimum to the maximum to describe this group? We have multiple numbers in this instance. Data does not have to be numbers, but in this instance, we have multiple numbers, and we need to make a decision based on those numbers to answer a question that we have. Okay, let me give you another example. Which plant is taller? If we've measured the height of the plant and we know our basic numeracy, subtraction, we can figure out what the difference is between 80 centimeters and 52 centimeters. And that can give us the answer to which plant is taller. Which group is taller is a more complicated question. The same way when we were talking about once we have a group, we have data, once we have multiple numbers or multiple images or multiple words that we are using to describe something, a group, a system, a phenomenon, we have data and we need to make some decisions. The computer can't make the decisions, AI can't make the decisions. A human has to make the decision as to what we want to do, how we want to go about answering that question. And this is important because whenever we are talking about a group, even if it's just the subdivided portions of a group, as in who likes red or who likes blue boar, or which Halloween candies we found, or did the large car or the small car go faster down the ramp? These are all group questions. We are thinking about the group. And whenever we're talking about a group, we are dealing with variability. There is going to be differences among the individual measurements or the individuals from which we are collecting data or from whom we are the like precursor is you have multiple things, multiple numbers, words, letters, images. Point number one, there's variability. Sometimes things vary a lot. Thank you, Cape Cod potato chips. Rock out from Massachusetts. Sometimes things don't vary very much, like Pringles. That's sort of their whole shtick beyond like once you pop, you can't stop, is that pretty much every chip is the same. But in reality, it's not actually. There is variability across those chips. And number two is that when we're working with data, it is always a sample of the whole population. We cannot collect information on every single instance and every single variable or attribute of each of those instances in whatever individual system or phenomenon that we are looking at. So we have to think about and ask ourselves, how representative are the data of the whole population? And here, population isn't like population of people, though that can be the case if you're actually asking questions about people, but it's just every instance in the whole world that could exist for that thing that you are trying to measure. So if you're doing an in-class experiment or investigation and you're looking at, say, how plants grow in the light or the dark, you're going to have some plants that are set up in the light treatment and some plants that are going to be in the dark treatment. But that is still just that's still just a sample of all plants in all levels of light and darkness. So we always have a sample. And so that we have to think about this question: how representative is that sample of the whole? And along with that, in terms of how representative is what is in the sample and what is missing from the sample. Or if we're working with people who are missing from the sample, things like that. And so because we know that there's always variability, we need to use that to make sense of it, and we need to consider the parts of the sample. So rather than just making blanket generalizations, conclusions from Terry and Chris's baskets that they threw at the back, like at a hoop in in one game or 5 minutes of that game, maybe we want the whole game, or maybe we want more than 2 players, or maybe we want to look across players of different abilities, or maybe not. Maybe we're only interested in comparing Terry and Chris in that one individual basketball game. And that's fine, but that's where our question must be. Our data needs to be tied to the question. We'll come back to that a little bit more as we go forward. Another important thing to think about when we're thinking about what are data is that data have units. It cannot be a naked number. It cannot be just an image without any context for what that image is, or words without any context for what that's telling us. That's a novel. That is great. That is important, but that is different than data. And there are two different kinds of units that we can use. We can use relative units. So arm span is a relative unit. It's relative to something that you or the user or that I am familiar with. The key thing is, though, it's that it is not standardized. So my arm length, my arm span will be different than yours and will be different than your students. And that's okay as long as we talk about in terms of Kristen arm spans or your name arm spans. It gets a little tricky though if we're trying to make comparisons or pool our data across lots of different people's arm spans. Hence standardized units. So a foot or a yardstick or a fathom is a standardized unit of measure, meaning that anyone who picks up a ruler stick that is 1 foot long will be able to use that same standardized unit of inches within a foot, regardless of if it's me or you or your students. That's a standardized unit. So thinking about that, there are affordances of when it's helpful to use relative, when it's helpful to use standardized units, but it always has a unit. And last but not least, as we're wrapping up here, we visualize data to make sense of it. So that kind of begs the question of what do we mean by data visualizations? And we're going to be jumping in a lot to data visualizations throughout the semester. So just a quick little sort of making sure we're all on the same page. Visualization is a process of making visual whatever is communicating specific knowledge. So it's just a way to make something visual for those of us that are visually able. Now we have sonification and multiple other ways to enable people who are not visually able to, in essence, visualize or understand what is included in it. An infographic, maybe is a word that you've heard of, maybe you've probably seen many of them, is something that provides visual cues to communicate information through colors, through text, through images, through data visualizations as well. But it is the whole thing. It's all about providing sort of a certain style of visual cues more than just written prose on a page. But I included that data visualization piece in there. So let's jump into what that is specifically. It's a way to visually represent or a visual representation of data. How do we look at data is a data visualization. Or it can also be the practice of visualizing data, the practice of taking data from individual numbers, words, images, and looking at it together as the full group and then making sense of it, that practice of visualizing it, or creating a visual representation for somebody else to look at and make sense of. As we're working with data, we want to think about how do we move from data of the value, number, text, images, values stored in a specific location, and work with it to get to an impact. There's always a purpose of why we're looking at data. An impact is where we have an influence or an effect on sort of long-term behaviors or decisions or processes, even if that long-term impact is on teachers, on like students' understanding of content, or teachers. We're learning too all the time. Or it can be as big as influencing a city making a different decision or a school board making a different decision based on the data that we have. Okay, but we're looking to move from value or values stored in one location through understanding what the information, gaining knowledge and insight and wisdom up towards impact. That's what we're working towards. Okay, so that was sort of a quick run through of what are data, what are components of data, things that we need to think about. So again, I'm going to invite you to pause the recording and think about now, what are 3 words that come up when you think of data? What are 2 questions that come up now when you think of data? And then what's a metaphor or simile that now comes to mind when you think of data? Okay, so pause the recording, write these new responses down to your 3, 2, 1, and then come back. Okay, got them? Got your new ones and your initial ones? Awesome. Now I want you to think about the bridge. How do your new responses connect or shift from your initial responses? Just jot down a few ideas, doodle a picture, whatever works best for you. But think about how in these last 15 minutes, what are some changes? What are some shifts that have happened in terms of thinking about data? Thank you so much. I look forward to continuing to work with you and talk with you about components related to data. If you have any questions or requests for more information or clarification, please feel free to contact me. I'd love to talk to you. Good luck with it all and talk to you again soon.